Okay, good afternoon and welcome everyone. So today we're going to start element number 10 of IG2, which is related to fire safety. Okay, so the learning objectives of today's session are number one, so that you become able to describe the principles of fire initiation, classification, and spread. So you need to understand how fire is started, how is a fire initiated. Then we'll discuss about the different types of fire and the classes of fire, and we will also discuss how fire is spread. Also, describe the basic principles of fire prevention and the prevention of fire spread in buildings. We will also discuss about fire alarm systems and firefighting arrangements for a simple workplace. And we will describe the factors which should be considered when implementing a successful fire evacuation of a workplace. So fire is a very, very dangerous, what you call it, substance. So we need to make sure that we manage it properly so that there is very less harm to the people. Okay, fire initiation, classification, and spread. Fire initiation means how does a fire start? Then we'll discuss the types and how it spreads. So basically, fire, it is a combination of three elements. Okay, this picture you can see here on the right. This is also called the fire triangle. Okay, some people also call it the fire tetrahedron. Okay, so basically there can be no fire if any one of these elements is missing. Okay, so all these three must be present in order for a fire to take place. Okay, so first of all we need heat. Okay, heat is basically the source of energy. Okay, the energy which causes the fire to start, it is heat. Okay, then there is oxygen. Oxygen is basically a gas. It is present in the atmosphere at around 21%. Okay, and then finally there is fuel, something which has to burn. Okay, so heat starts the fire, or that's the energy which is required to start a fire. Oxygen is a very, very important chemical reagent of the fire process. And then fuel. Okay, so fuel is what burns. Anything which is combustible, anything which can catch fire is called the fuel. So fuel is basically a combustible materials or substance consumed during the process. Oxygen is from the air, which is 21%. And or we can get oxygen from oxygen enriched substances as well, such as oxidizing agents. So basically the oxygen in the atmosphere exists as O2. Okay, so that's the oxygen gas which is required for a fire to start. And then heat or ignition source is required to start the combustion process. Okay, so these are the three elements of fire and three components of fire, and this is called the fire triangle. Now keep one thing in mind, guys. If you remove any one of these, okay, if you remove any one of these, a fire will be extinguished. If you remove heat, a fire will extinguish. How do you remove heat? You remove heat by lowering the temperature of the fire down. How can you do that? You can do that by throwing water on a fire, or you can do that by using what you call it, carbon dioxide, a fire extinguisher, which reduces the temperature of the fire, so there is not enough heat energy to sustain the burning process. Okay, so fire basically, wherever a combustion happens, there is one process which is going on. The carbon which is present in the fuel, it combines with the oxygen in the presence of heat, and it forms carbon dioxide, CO2. Sometimes This carbon dioxide, it is CO, carbon monoxide. Okay, this carbon monoxide is very, very poisonous, and CO2 is also, it is an asphyxiant. So both of these gases are not good. But the only thing which I want you guys to remember is that whenever a fire happens, this is the main process which takes place. The carbon from the fuel, it combines with the oxygen to form CO2, and unburnt fuel generates carbon monoxide. Okay, so if the combustion process is not effective, then obviously carbon monoxide is generated as well. Okay, so this was the fire elements, the three elements of fire. Let's move on the principles of fire. Fire basically, it's a rapid chemical process in which oxygen combines with another substance, fuel, in the presence of a source of heat. The reaction is called combustion. So the process of a fire taking place, it is called combustion. That is why you heard the terminology combustion engine. Combustion engine means an engine in which there is a fire. Okay, so combustion engine is fitted on all vehicles, and all the vehicles, they obviously burn fuel, they burn petrol to make their cars run. Okay, so combustion is the process of burning fuel, or you can also say combustion is fire, a fire taking place. So during this reaction, heat, flames, and smokes are produced. So there is heat, obviously, that is produced, flames and smokes as well. What are the various classes of fire? Basically, there are total 5 classes of fire. Class A fire is the fire involving organic solids. Okay, so the fire in solids is referred to as a class A fire. A fires happen in wood, paper, plastics, etc. Then there are class B fires, which are fires involving flammable liquids such as petrol, paint oils, and liquefiable solids such as fats, waxes, greases, etc. Then there is class C fire. Class C fire, fire involving gases, okay, such as butane and propane, etc. Class D fires are fire in metals. And then there is class F fire, which is fire in commercial deep fat or oil fryers, etc. Okay, so how does fire spread? Fire spreads the same way heat spreads. So the heat transmission leads to fire transmission. So when the heat is transmitted from one object to another object, the fire is also transmitted as well. The most common process of fire spread is direct burning. So if there is already a fire somewhere and there are other combustible materials in the area, so they will catch fire by direct burning. From the direct heat of the ongoing fire, the other fuel, it will catch the fire, and this process is called direct burning. Then there is convection. Convection basically is the movement of fluids such as gases. Okay, so the movement of fluids, what it will happen is that it will carry the heat from one place to another place, and then it will move the fire as well. It will spread the fire as well. There's a very simple example I will give you. If there is fire starting on the ground floor of a building, okay, where does the next fire happen? The next fire happens on the topmost floor of the building. And why is that? That is because of convection. So whenever a fire is there, the fire has so much heat energy that it basically what you call it makes the air hot. Okay, and the molecules of air start vibrating, and hot air basically, it is lighter than cold air. So the hot air, it has all this heat in it, it rises to the top floor and it takes the heat with it as well. So that heat later on goes to, if there's any fuel available, it will cause a fire there as well. Okay, next is conduction. Conduction is basically the flow of heat through solids. So when a fire transmits through solids, from solid to solid, it is called conduction. And then there is radiation. Radiation is the transfer of heat without any medium at all. So fire in spread of fire in solid is conduction. Spread of fire in liquids and gases or fluids is called convection, and direct fire without any medium is called radiation. Direct burning could be a combination of all of these or a few of these. Okay, so here you can see in convection, what has happened is that the fire started on the ground floor. Okay, now the air is getting hot. So the hot air escapes through the door, rises up from the staircase, goes to the next floor. And then it will start catching fire over here as well, wherever there is fuel. Okay, so this is called convection. Then there is conduction. In conduction, you can see, so in conduction, you can see that the fire is spreading through solids. Okay, so this is called conduction. Then there is radiation. Radiation is the transfer of heat. Radiation is basically the transfer of heat. Just 1 second, guys. So the transfer of heat without the need of any medium is called radiation. So if a fire starts in one house, it can easily move to another house. Okay, let me just close this. Okay, suggest common fires, common causes of fire in the workplace. Now, who is going to tell me from the group members? Puneet, you raise your hand.
Yeah, so I have question. One question regarding the radiation.
Yes.
Is there this radiation can spread with the electric items also, the end when there's a fire in another room and there is wires coming from one room to one house to another house or something like
No,
that.
that will fall under conduction.
Okay, sir, then please explain the radiation. I didn't.
Radiation does not need any medium to transfer through. The sun is sending us heat, right? We get heat from the sun,
Right.
correct? How does that reach to us? There is no medium, it is space, it's empty space. There is no fuel, so there's no liquids there, there's no gases, there are no solids. So basically, how does fire spread? How does heat spread? The heat spreads whenever you heat a material or an object, you are actually giving it energy. Okay, so with that energy, the molecules or the atoms of that material or that substance, they start to vibrate. Okay, they start to and fro motion, and they, because they are getting energy, they are getting heat, they are getting energy. That vibration, okay, they are hitting other what you call it, molecules nearby, other atoms nearby, and then they are transferring some of that energy which they have absorbed, they're sending it to them. So this is how the heat transfers in solids or liquids, okay, and gases. So whenever you heat something, it gets energy, the molecules or atoms start to vibrate, and then they heat each other, and then they what you call it they transfer the heat, and then obviously the fire spreads by this process. So conduction is the transfer of heat through solids. Convection is the transfer of heat through liquids and gases, or you can call them both fluids as well. Radiation is the transfer of heat without any medium. Okay, so this, for example, the heat energy from the sun, it reaches Earth through radiation. What is radiation? Basically, radiation basically it is the waves of energy which are transferring. So heat is basically packets of energy which is being transferred in the form of waves. Okay, that is radiation. So these are the three methods of heat transfer: conduction, convection, radiation. Conduction
Okay, sir. Thank
basically,
you.
okay, conduction is solids, convection liquids and gases, and radiation is without what you call it any medium. What are the common causes of fire in the workplace? Anybody who can tell me?
The short circuit, sir.
Short circuits. Somebody has said cigarette butts. Yes, cigarette smoking is a common cause of fire. What else?
So commonly this common combustibles like class A fire in the area sometime from the material office material
Yes.
sometime
Yeah, you can
yeah
say.
common combust class A fire.
Yeah, class A
Then
fire.
there
But
is
what
a
is the
class
cause? What is the cause? Cause, reason.
the yeah the
What is the
reason
cause
is
of fire?
The welding works near the combustible material, sir.
Exactly. Carrying out hot works, carrying out welding, cutting, grinding near combustible material. That is a cause of fire. Okay. What other causes of fire can we have? Mohsin?
Sir, flammable substances at the workplace.
Storing
Liquid.
excessive flammable substances at the workplace, yes. But how will the fire start? Obviously, there will be some heat, some source of heat available. Okay. So usually, now there's one thing to remember in fire. Fuel is almost everywhere. Okay. So there is fuel in your house. You're sitting on a sofa, it can catch fire. You eat dinner on a table, it can catch fire. So everything around you is fuel. Even you can burn, you are also fuel. So fuel is available almost everywhere. Okay, material substances which can burn, they can easily be found. The second thing is oxygen. Oxygen is also available everywhere in the guys, please don't write on the screen. So oxygen is also available in the atmosphere. Okay. So oxygen is everywhere. Fuel is almost everywhere as well. The only thing which is lacking is the heat. Okay. The only thing which is missing is heat. So as soon as we have sufficient amount of heat, fire will start. So that is why in the causes, most of the time we mention the sources of heat, we consider them as the causes of fire. Okay. So, but yes, you can also mention that improper storage of flammable gases can also be considered a cause of fire. But mostly think of sources of heat. Okay. Wherever there is sources of heat, that is considered mostly a source of fire. Okay, the causes here are electrical equipment. Okay, electrical equipment, how are they a cause? Obviously, when you have electrical equipment, which is, if it's not maintained properly, it might be sparking. Okay, it will be generating sparks. Those sparks have sufficient energy to cause a fire. Or if electrical equipment gets overheated, okay, if there is too much load on an electrical equipment, the electrical circuit, it becomes overheated, and that excessive heat is dispersed into the environment and it can cause fire. Then there is deliberate ignition. Somebody setting a fire on their own by using a lighter or a match or something. It is also called arson. This is a criminal activity. Somebody who deliberately ignites or starts a fire is a criminal act, and it is called arson. Hot works, okay. Hot works, what does hot work includes? It includes welding, cutting, grinding, okay, burning, soldering. So all of these activities are hot works. Then there is smoking. Obviously, that's another common fire. People throw cigarette butts around and they can cause fire. Cooking appliances. Okay. So cooking appliances, obviously you cook food in cooking appliances and they are obviously hot and they can cause fire. Heating appliances such as a heater, a water heater, a room heater. So the heating appliances can also cause fire when they are overheated or when there is some combustible material near them. Unsafe use and storage of flammable liquids and gases, yes, as I mentioned, that is there. Mechanical heat, what do you mean by mechanical heat? Mechanical heat is the heat generated by the machinery or the equipment. Obviously, when the machinery is working, it has some moving parts in it. those moving parts, they strike against each other. And when two solids strike or rub against each other, there is something called friction. That friction, it can cause fire as well. It is that is, in fact, that is how fire was invented actually. Okay, so you remember in old videos, in movies, you must have seen that people, they rub pieces of wood together to start a fire. Now, what is causing that fire? Rubbing pieces of wood together. What's happening now? Now, when you rub two pieces of wood together, there is friction between those two pieces of wood. That friction, it causes heat. Okay, so whenever you, for example, you want to warm your hands in the winter, what do? You rub your hands like this. Your hands will go warm. Why? This is because of friction. So friction generates heat. So this mechanical heat from is caused from the friction of the various parts of the machines. And then obviously there are chemical reactions which generate heat as well. So these are all causes of fire. So remember guys, this is important causes of fire, because this is what you will consider as hazards. These are all hazards which you can write in your risk assessment. Okay, so these are all hazards which you can write in your risk assessment in under the fire hazard category. Okay, let's move on. What are the consequences? Obviously, people get killed and injured, damage to buildings and contents, including smoke damage, environmental damage, water runoff. Now, there is one important thing to remember. People die from fires, okay? But they don't die from the fire itself. They die, majority of the deaths happen due to smoke inhalation, okay? Smoke inhalation is what causes most of the fatalities or deaths, okay? Because the smoke is toxic, it is poisonous. It has carbon dioxide, carbon monoxide, it will have soot, it will have pure carbon, unburnt carbon as well. So the biggest killer is not the fire itself, it is the smoke. Okay, then obviously it could cause environmental damage, for example, water runoff as well. So these are all the consequences of fire. Okay, what are the three things that need to start fire? Fuel, heat, oxygen. What are the methods of fire spread? Convection, conduction, radiation, and direct burning. And the common causes of fire we have just discussed as well. How do we prevent fire, and how do we prevent the spread of fire? Okay, so these are the control measures. The control measures to minimize the risk of fire in the workplace include, first of all, control of all combustible and flammable materials. So what are you doing by controlling combustible and flammable materials? The solid, liquid, and gases, these are all types of fuel. Okay, whatever burns is called fuel. So you need to control the fuel. So you need to control the combustible and flammable materials. So if you control the combustible and flammable materials, you can minimize the risk of fire. You will not be able to eliminate it completely, but you will be able to reduce it. Then control of ignition sources. Okay, so control of ignition sources. What are the ignition sources? These are the sources which provide heat energy. Okay, so there is friction, that is a source of ignition, damaged electrical equipment, damaged electrical cables, okay, friction of the equipment or machinery, hot works, cutting, welding, grinding, okay, engines of vehicles, okay, sparks, generated friction. So all of these are the sources of ignition. So you need to control the sources of ignition, provide a safe system of work, have a smoking policy, and install CCTV to control arson. So these are the control measures that you can use to control the ignition sources and prevent a fire. Then use of electrical equipment in flammable atmosphere. That is another what you call it cause of fire. So you need to basically make sure that you classify the various hazardous zones and use equipment according to those classifications. Basically, there are zone 0, zone 1, zone 2. Every country has their own classification. You don't remember, you don't need to remember this, but zone 0, zone 1, zone 2, these are various various hazardous zones which are defined in terms of flammability. A zone 0 basically is an area or a zone where there is always a risk of fire. Okay, there are so many hydrocarbons in the atmosphere. For example, oil refineries, oil processing plants. So these are zone 0. Then there is zone 1. Zone 1 is basically when a flammable or combustible atmosphere exists in that environment from 10 to 1000 hours per year. Okay, and zone 2 is basically a zone in which there is a very little risk of fire, and the combustible atmosphere exists only for up to 10 hours in a year. Okay, so less than 10 hours in a year, if there is combustible flammable atmosphere, then it is classed as a class zone 2 area. So zone 0, 1, 2, these are various areas of classification due to fire. Okay, then obviously you need to install safe systems of work to control hot works, control machinery and electrical equipment, etc. And obviously good housekeeping is also a very good control measure to prevent the start of fires. Okay, what are the control of combustible and flammable materials? Obviously, you should try to eliminate the use of combustible and flammable materials altogether. If not, then substitute for something which is lower risk, or which has lower flammability, what you call it, temperature. Then minimize the quantities. Don't store extra quantities of flammable or combustible material, and make sure you there is safe use and storage, and it is in dedicated building. Okay, so another control of combustible material is in terms of gas cylinders. Okay, so gas cylinders, they should be stored outside in the open air so that there is adequate ventilation. The storage should be fenced with a secure lockable gate so that nobody can play around with it. Warning signs should be displayed. Ignition sources must be eliminated from near that vicinity. Bottles, the gas cylinders, they should be changed upright. They should be fixed to a cage, and they should be in upright or a vertical position. They should not be lying down on the ground. Separate from other buildings. Obviously, you need to make sure there is a separation between other buildings so that fire does not spread from one building to the other building. Empty and full bottles, they need to be separated. Oxygen bottles must never be stored with LPG. And finally, you should return to the store immediately after use. There is a question here. Let me just check, guys. What is the question here? Avoiding of filling vessel cylinders, fuel tanks of cars empty completely to avoid tank bursting due to heat and pressure in hot climate. No, basically that there is no truth in this. Azhar posted a message that you should avoid filling vessel cylinders, fuel tanks of cars completely to avoid tanks bursting due to heat and pressure in hot climate. See the cars which have a fuel tank, they are fully designed to withstand the pressure of the fuel which is generated by the hot weather. Okay, so there is no fact in this. Your car will not catch fire, your car will not explode if you fill it to the brim in the summer. This is guaranteed. Okay, so Muhammad Azhar, there is no truth in this. Okay, so these are the control measures. Yeah, this was a rumor which went around. It was actually a hoax. It was a hoax news which went around. Because the car designer, they designed the fuel tank to sustain all this pressure and all this temperature. Otherwise, every other card would start exploding. Okay, moving on to the next slide. Yes, and control of ignition sources, very, very important. Make sure the electrical equipment is in good condition. It does not overheat. Make sure the hot works are carried out in a controlled manner under a permit to work system. Make sure smoking is carried out only in designated areas. Make sure the cooking and heating appliances, they are in good condition, and they must never be left in use without an attendant, because they might get overheated and start a fire. Mechanical heat should be controlled by reducing friction, regular maintenance of the machinery, making sure that the parts of the machinery are adequately lubricated so that they don't generate heat because of friction. And we also need to install CCTV camera if required, to avoid deliberate ignition. Okay, so the use of electrical equipment in flammable atmosphere, that's another common cause of fire. So you need to make sure that you only use fire rated equipment in flammable atmosphere. Okay, so obviously flammable atmosphere can be very, very explosive. For example, working in an oil refinery, working in a plant, there might be a lot of flammable gases in the atmosphere, or vapors, etc., or even dust, it can catch fire as well. There is something called dust explosions. So if dust is in a confined area and it is in a certain mixture in the air, it can even the dust, it can catch fire and it can explode as well. Okay, so you need to make sure that you try to avoid try to what you call it, dilute the air, provide proper ventilation to prevent the accumulation of flammable gases and dust mixture. See, if you have only fuel gases, if you have a gas, it will not catch fire on its own unless there is a flammable mixture. Okay, there are something called the flammability limits. There is the lower flammability or lower explosive limit, and then there is the upper flammability or upper explosive limit. A fire will only take place if the percentage or the concentration of the fuel in the air, it is within those ranges. So if, for example, H2S, it is a flammable and combustible gas, the flammability limits are lower explosive limit is 4%, upper explosive limit is 40%. So if there is less than 4% H2S in the air, even if you ignite it, there will be no fire, there will be no explosion. And if there is more than 40% H2S in the air, again, there will be no fire, there will be no explosion. But if the percentage of H2S in the air is between 4 and 40%, it will definitely catch fire and cause an explosion. Same thing is with dust as well. Dust also has its flammability limits. Vapors, they have their own flammability. So every type of fuel gas or every type of fuel, it has its own flammability limits. So that is very, very important to remember as well. So electrical equipment, it can ignite this mixture. Okay, so electrical equipment, basically when there are loose connections, loose cables, they generate very, very small, very minor sparks. Sometimes those sparks are invisible, you cannot even see them. Okay, that is, sometimes that is enough energy that from the electrical equipment that can ignite a combustible mixture. Okay, so that is why when you work in the oil and gas refinery, you are not allowed to take in your mobile phones in there. There are specific mobile phones which are called intrinsically safe mobile phones, which you can take to the in flammable atmospheres. So there are various national and international legislation to control this. Zone 0, Zone 1, Zone 2, these are the zones of fire which I discussed earlier. Zone 0 is a place which is an explosive atmosphere is present continuously for long periods of time. Zone 1, a place in which explosive mixture is likely to occur in normal operations, usually 10 to 1,000 hours per year. This is just 10 to 1,000 hours per year. This is an ad hoc specification, but you can keep in mind that zone 1 is a place in which explosive atmosphere is likely to occur in normal operations. Zone 2, a place in which an explosive atmosphere is not likely to occur, and if it does, it will be only for a short time. Okay, then electrical equipment, again, you need to use the different categories of electrical equipment as per the zones. So category 1 equipment can be used for zone 0 zones. Category 2 equipment can be used for zone 1 zones, and category 3 equipment can be used for zone 2. Okay. Then there is the permit to work system. The permit to work system is a very, very important control measure to control the fires. You should remove all flammable materials from the area, cover the items if they can't be removed, sweep the floor, make sure there is good housekeeping. You should also damp down the wooden floors as well so that they don't catch fire. You should provide suitable fire extinguishers, ensure the fire watcher is available, and check the area after the work is finished. Good housekeeping is also helps reduce fire. The area should be waste free, tidy, well ordered. Pedestrian routes should be clear. Flammable material should be stored properly as well. Make sure the temperature is controlled in the flammable material area. Make sure there is adequate ventilation. Okay. So you need to make sure that you control the flammable materials and liquids. There are various categories of liquids. Category 1, 2, 3. Category 3 liquids are flammable liquids. Their flash point is between 23 and 60 degrees. Then there is category 2, flash point between is less than 23 degrees. And category 1, which is highly flammable liquids, flash point is less than 23 degrees and boiling point is less than 35 degrees C. So these are various categories. Okay, what are the safety precautions for storage of flammable liquids? Obviously, you need to make sure that you use the minimum volume of liquid required. Don't store any extra flammable liquid on your site unless it is necessary. Liquids should be in a properly labeled container. The container should be of metallic and self-closing lid. Metal drip trays should be used to catch the spills. Use away from the heat ignition sources. So store flammable liquids or use the flammable liquids away from ignition sources. Ensure the workplace is well ventilated, and return the containers to safe storage area after use. Okay, so, always use small quantities, use minimal quantities. The store should be sealed properly. The flammable cabinet should be fire resistant, lockable lids, and clearly signed. Drip trays should be available as well, and it should be away from the ignition sources. When you are storing larger quantities, you need to have purpose-built single-story flammable stores and segregated from the chemicals as well. So you cannot store different types of chemicals together. You have to give them separate. It should be built of non-combustible material, should be lightweight as well, and explosion-proof roof should be there. Built outdoors away from other buildings. The store should be suitably fenced in a secure area. Electrical systems should be intrinsically safe. So wherever you are storing flammable liquids, the electrical equipment in that area, it should be intrinsically safe. Store being well ventilated, access doors should be lockable, fire extinguishers should be available, regular checks should be carried out, and clear, safe access should be provided to the fire services, fire brigade, etc. Then compartmentation is another control measure to prevent fires. So compartmentation is basically when you split a building or a facility into various compartments, so that if there is a fire in one compartment, it does not spread to the other compartment. So basically you can do that by providing fire break doors between the various parts of a building. For example, if you go into big buildings, you will see that there is a door after every 20-30 meters. That door is a fire resistant door, and that basically is helping in making a compartmentation on that building. Okay, so creating enclosed or sealed boxes using fire-resistant materials. The fire is contained in one part of the building and only fully effective if the openings of compartments are sealed as well. And local building regulations are important in making compartments as well. Okay, the door of the compartment, it has certain characteristics as well. It should be able to withstand 30 minutes of fire. It should be fitted with self-closing devices. Instrument strip should be fitted. Cold smoke seal should be fitted as well. Vision panel should be there. Should be clearly labeled as well. Okay, there's some building material and their properties. Concrete usually performs well in fire. Steel is severely affected by higher temperatures. Brick is usually resistant to fire. Thin timber will burn quite quickly, and thick timber will survive for longer. Surface treatment, basically, it can help improve the fire performance as well. Insulation, obviously, it can help prevent fires, and wall coverings should also be provided as well. It should be fire retardant. Opening and voids, obviously, you need to make sure they're controlled, otherwise fire or heat will spread through it and cause fire as well. Self-closing shutters should be given, fire break walls should be available, and there should be procedure to seal any new openings as well with fire retardant foam. Then we have fire alarm system and firefighting. There are various types of fire. Simplest is shouting fire, fire, fire. Then there is handbell whistle as well. Manual call points are available. There are interlinked smoke alarms, in which smoke alarm, if it goes off in one part of the building, it will raise the alarm, and there are automatic fire detection and alarm system. Smoke detectors are there. They detect small particles of smoke, and they give a beeping sound, and it can give it can also give false alarms as well. Then there are heat detectors that monitor the temperature and give off the alarm when the temperature exceeds a certain limit. Okay, portable firefighting equipment, obviously we need to provide them as well. Most commonly we have fire extinguishers, fire blankets. A fire blanket is basically a special type of a blanket which is fire resistant, and it can help prevent fires. Hose reels, sprinkler systems, all of these are firefighting equipment. So here are the types of fire and on what fire extinguishers, so on what types of fire can we use the various fire extinguishers. Not important for your exam, but you can still read through it. Class A fires, you can use water, foam, and powder. Class B fires, you should never use water, but you can use foam, carbon dioxide, and powder. Class C fires, fire in gases, you can use only dry powder. Class D fires are metallic fires, again, you can use only dry powder. Class F fires are basically fires in fats, and you can use a wet chemical on those fires. Electrical fires, you cannot use water, you cannot use foam because you will get electrocuted. So you can use CO2 and powder. Okay, maintenance and training is very, very important. You need to make sure that you train the people on the fire exit routes, fire procedure, where the fire exit doors are, and properly signed, and unobstructed access should be provided as well. Regular inspections should be carried out in the workplace. Maintenance of the equipment is also very important. Obviously, training can be of different types. There could be theory training. Then part of that is the types of fire extinguishers, give hands-on experience to the workers, and record the training, what you have done. Access should be given for fire and rescue services. This is very, very important. Most of the time, you must have seen outside various buildings, there is a dry riser or a wet riser. That basically is the point where the fire pump comes and it can connect its pipe, and the whole piping system is available inside, and you can extinguish the fire using that as well. Okay, fire evacuation. What do we do in case of evacuation? You need to make sure they're available. The means of escape are available to every person in the workplace. It does not need the use of lifts unless there are special cases. 2 or more separate routes must be required at all times for evacuation. Travel distance should be short enough. adequate width should be there, should be clearly signed, appropriate lit and emergency lighting should be provided. The travel distances, it depends on the number of people that are in the room, the travel distance from the nearest available first exit. So you need to make sure that you identify what is the travel distance so that you can advise the people where they need to evacuate through. So also you need to mention the fire risk as well. The fire risk, it will also help you in identifying the travel distance and the number of alternative escape routes available as well. Stays and passageways should be fire resistant, adequately covered, unobstructed. Doors should be easy to operate, adequately fixed, and open in both in the direction of travel and should not be locked. Emergency, basically at the night or where there is no natural light, you need to provide emergency lighting to indicate the escape route. So people in the night, if they need to escape, they should be able to escape easily. Regular maintenance and inspection need to be carried out. Exit and directional signs should be provided. So standard shape and standard color signs should be given as well. Assembly points. So whenever people leave their building or evacuate the building, they need to gather at the assembly point, and they should gather in a way that the head counting is easier. Okay, moving on, emergency evacuation procedures. You need to know what to do in case of an emergency or a fire, so train your people as well. Fire marshals are very, very important. They check all the evacuated areas have been evacuated or not. They assist disabled or infirm people, ensure that the first escape routes are kept clear at all times, windows and doors are closed, and a roll call to be carried out as well. The roll call basically ensures all persons accounted for. You need to have provisions for the disabled people as well. For example, a person who cannot hear, okay, so you need to have a flashing alarm for him. If he cannot hear the fire alarm, he will be stuck and he will die. So you need to give what you call it some consideration to that as well. You may need to consider temporary disabilities, consider also the evacuation of the young and the elderly. Okay, building plans and escape routes are also quite important. Sorry. So plans, developing plan is very, very important. And in order for you to develop a emergency plan or a fire plan, you need to identify who is likely to be in the premises. You need to decide on the actions to be taken in case of fire. You need to identify the escape routes in the emergency plan. You need to mention what actions are to be taken after evacuation, and you need to give training as well. Okay, what should the training include? The training for the employees, contractors, and visitors can be used as well. You should also train your staff on how to use a fire extinguisher and how to become fire marshals, and make sure that they are they have adequate information so that they can fight fires. Fire drills should be conducted regularly, at least once or twice a year. Staff must participate in it and allow for the testing procedures to go on as well. Okay, guys, so this is the end of element number 10. So what we'll do now is we'll take a small break, okay? And after the break, we will start element number 11 and we'll try to finish it off today. So is there any question, guys? Do you guys have any questions related to this session? Any queries?